Hello students, we are here to discuss something on your MIS syllabus. We will discuss today about your module 6 of your MIS syllabus, which is on computer networking. So basically, what is computer networking? So computer networking means when we connect two or more machines via a single communication channel via a communication channel. That becomes basically network. So computer network means when we are connecting among different computers. So it's basically creating a computer network. So why we are creating the why we are connecting different computers? Because we want to share data. We want to share about different kinds of data. It may be voice, it may be text. We want to share. When we want to share, we try to connect between them, and through connection, we make communications actually. So that is basically computer network. So there are different types of computer networks. Today we will discuss on different types of computer networks. What are the frequently used terms in computer network? What are the rules and regulations we generally follow in computer networking? Mm, Then we will discuss on some techniques and some technologies related to computer network, some devices which we use in our computer networking. So these things we will discuss today. So computer network is very vital thing nowadays. Actually, not only computer network, computer, mobile, or different devices are connected via networks nowadays. That's why we can communicate. So this is very important. This is very important in today's business scenario also, especially in this situation when our total entire world is locked down and we have to perform all our jobs, we have to accomplish all our tasks from home. So computer networking taking a very vital role. It's playing a very vital role in this overall scenario. So not lending this thing, we are just starting our syllabus. Okay, so I will share one screen with you with the notes, and the notes is there, and notes is also already shared with you via the Google Class and in WhatsApp groups. Add-on, I am uploading this video so that you can get more information from this video apart from the notes. But I will generally what I will do is I will explain the notes to you so that you will get some help from it. And later on, if you have any queries, any doubts, please ask me via Google Class or via WhatsApp, or you can make me call. You know my number. You can make me call. So I'm preparing this video solely for my BBA students, BBA second year students. This is the part of their MIS syllabus. So let us start the syllabus. Let's start the study. Okay. So I'm sharing the notes with you basically. Right. So I hope all of you can see this note. It is coming into your screen. So at first, I've written what is computer network. So computer network, as I told you, it's a group of devices connected with each other through a transmission medium such as wires, cables, etc. These mediums can be sometimes guided medium, sometimes unguided medium. Guided medium means that wires, that cables, what you can see, you can touch it and like that. Unguided medium means lots of unguided mediums like satellite communication, like different other kind of communication like microwave communication. So different other unguided mediums are there. So there are different kinds of medium: guided medium, unguided medium. Under the guided medium, it is the wire, coaxial cable, optical fiber cable. These are some guided medium because we can touch it, we can feel it, and like that. Unguided medium, like satellite communication, like any other wireless communication, we cannot touch the wire. There is no wire, no physical wire is there, but there is some medium obviously. Otherwise, the communication is not possible. So there are different kinds of medium. So via any medium, when two or more computers are connected, two or more devices are connected, rather electronic devices are connected, we can call this a computer. This is a network. And when the network is solely developed for the computer, we can call it computer network. So with a computer, you can connect different printers, scanners, fax machines, mobiles, etc., 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 different devices. So that is again coming under computer network. So the purpose of having computer network is to send and receive data. stored in the devices. Okay, and the devices are often referred to as nodes. In general term, we refer the devices as nodes. Okay, so nodes and devices are synonymous here. So that is about computer network. Now, there are few frequently used terms in computer network. I think these terms are very important to you. That's why I have included these terms in this particular note. The first term you may come with node, what I have already discussed. Node means the devices, the different devices which are engaged in the communication process in the network. That is nodes. Next is message. Now, message means the data what we are sending. The data can be sent in different forms. Actually, whatever data we send, ultimately it is done in 0-1 format actually, because all the communication is basically more. I mean, 90% communication we make in a digital form. Some communication we make in analog form also, but our computers or our electronic devices are more or less it is digital devices. So actually, the form is only 1 and 0. So now there are different terms, as I told you. That message is one term. Message means actually the data, the information which needs to be transferred from one device to another device. It is basically known as message. What is sender? The device which is sending the data, that is sender. What is receiver? The device which is receiving the data, that is receiver. Now there is a picture. This is a picture. This is the transmitting device. This is receiving device. The transmitting device sending data, and that and this data is not suddenly going to the receiver. There are some steps. In the step-by-step manner, the data is coming to your physical wire or or in the form of 1 and 0, and it's again going to the receiver sections receiving part, and there it is also going in the same form, that is 1 and 0, and then after that it is changing its form, and finally it is coming to you as a in a form which can be understandable by us. So basically, here I have shown that actually the whole computer communication is done under different steps. We will discuss that steps later on. I'm telling you, the steps are like that. If you start from the bottom layer, there are basically 7 layers of this communication. We call it generally seven layers of OSI model, that is Open System Interconnection Model. Now the 7 layers are starting from physical layer, then data link layer. The first layer is known as physical layer. This is the bottom layer, you can say, that is physical layer, then data link layer, then network layer, then transport layer, then session layer, presentation layer, and the application layer. Now what is the application layer? I'm starting from the application layer. What is the application layer? Application layer where the user is sitting on. That is the application layer. All the application softwares are running at that layer. So currently we are sitting on the application layer, where I am sending you some data, you are receiving that data. But in between these two things, there are lots of other processes are going on, and that process are these things. That process are basically these things. Okay, this is at my part, this is at your part. Okay, so this is at the physical layer. The data is, we are sending the data from the physical layer. Then it is coming to the this is at the present application layer. I'm sorry, this is at the application layer. We are sitting at the application layer. So this is at the application layer. So this is the top layer is the application layer, bottom layer is the physical layer. So this is at the application layer. Okay. Then this is at the presentation layer. This is known as presentation layer, where the data makes presentable to the receiver. This is presentation layer. This is session layer. At the session layer, actually what happens, we are creating the session. We are reserving the time to communicate. That is the session layer. Then this is the transport layer. This is the network layer. These two layers are very vital. Transport layer, the main protocol, main rule, set of rule. Actually, in computer network, there are some set of rules we use. Those rules are known as protocols. Okay. So in the transport layer, the main set of rules or protocol runs is known as TCP. There are lots of other protocols we will discuss later on, but this is TCP, Transmission Control Protocol, which runs at the TCP layer, which controls all these things. I mean, all the communication, all the data is a vital part. Next, IP, this is network layer, and network there is IP, Internet Protocol running on. So this is a kind of addressing scheme. Okay, so Internet Protocol running on. Then the data link layer, it is also very vital layer, data link layer, and then actually the data is coming to a form of 0 and 1. And it is transmitting via the physical wire or via some unguided media like satellite communication, microwave communication, and like that. And then it is coming to the receiver section, Now remember, in between them there are different nodes can be there, because that nodes are basically used as a path of your data to reach the destination. Okay, so now when the data is coming to the destination layer, destination node or destination system, destination machine, whatever you can say, again this is the physical layer. So this is in the form of 0 and 1, because our computer can understand only this. Then the reverse thing happens, and finally it reaches to the application layer of your system, where you can get the data. So this is basically an overall idea of how the communication happens. Okay. So as I told you, there are different protocols, set of rules we use in computer network. So protocol is a set of rules that are agreed by both sender and receiver. Both has to agree on the same set of rules, otherwise communication is not possible. Okay, there are different kinds of protocols. Some are known as connection oriented, some are known as connection less. Like TCP is connection oriented protocol, IP is connection less protocol. Obviously, connection oriented protocols are much reliable than connection less protocols. So if we see different protocols, different very important protocols, different very frequent used protocols. The first is known as TCP, transmission control protocol. Next is known as IP, that is internet protocol. Next is known as HTTP, hypertext transfer protocol. You can see whenever you going to open a web page, you will find this HTTP. Next is FTP, file transfer protocol, which is used to send some files, send and receive files. FTP. Then SMTP, simple mail transfer protocol. ARP is address resolution protocol. Now, some of the protocols are still in use. Some of the protocols are not used nowadays. Like nowadays we are moving from IPv4 to IPv6. IPv4 is Internet Protocol version 4. We are moving to the IPv6 version 6 model. In the version 6 model, some of the protocols has been merged, like ARP, RARP, this kind of protocols. ARP means address resolution protocol, which is used to find out the physical address of your machine if you know the logical address. Logical address means the IP address. Physical address is known as the MAC address. Actually, MAC address means the address which is present in your motherboard. Okay, that is the address, that is the actual address of your system, which is unique in the world actually. So if you know the logical address, and if you want to know the MAC address of your machine, you can run this ARP protocol. And reverse address resolution protocol just done the reverse thing actually. So that is the thing. Now this is the model what we are talking about, OSI model. Now OSI has 7 layers here. Physical layer, as I told you, physical layer, then data link layer, then network layer. So under the network layer, I told you the protocol most important protocol works here is IP, internet protocol. With them, ICMP, internet control message protocol, IGMP, internet group message protocol. These protocols also works. Now at the transport layer, main protocol is known as TCP. Alternatively, you can use UDP, which is known as user datagram protocol, UDP. So TCP is a connection oriented protocol, which is a reliable protocol. UDP is not so reliable because it do not provide a strong error detection correction mechanism. TCP provides us error detection correction mechanism. What is error detection correction? If you ask me, so I will tell you that error detection correction means, suppose I am sending this data to you. Now you are getting this data, or whether you are getting something else, or the data is distorted. That thing is checked by the TCP protocol. Okay. Now UDP do not check it so thoroughly. TCP checks it very thoroughly. That's why TCP is connection oriented and reliable, we call it. And when we need faster communication, we can use UDP. Okay. Next layer is known as session layer. Under the session layer, there are different job of the session layer. Actually, the main thing we can tell you that the establishment of the connection between two machines. So looking after the duration, for how long duration the connection will be established, and whether the receiver is in a position to receive the data or not. These things are monitored by session layer. Presentation layer, actually, if you think like suppose you are using Samsung mobile. Now somebody is using Micromax mobile. So the file system, the operating system, different the things can be different, but still you can communicate. So in the same way, when two machines were communicating between two machines or more than two machines, whatever be the thing. So some machines are running in Windows, some machines are running in Linux machine, some machines are Mac operating system, some machines are something else. So there are different rules, different file systems, different things are there, but still you can communicate. So that thing is basically done by the presentation layer. And finally, the application layer, when a normal user is sitting on and using some application software, like right now we are using this Zoom application software. The Zoom application, this is the Zoom application software. Okay, so we're using this software, so we're at the application layer. So you don't have to think much how this data is going to you. I mean, when it is going to presentation layer, when it is going to session layer, when it is going to transport layer, what protocol is basically actually used. you are using what is my IP address. I don't have to bother about this, and so you don't have to bother about this. You are just getting this data as because you are sitting on the application layer at your computer or of all of your device. So that is the thing. That is the in that way communication happens. This is basically RSI model. One set of one model is this is the one model of communication. 7 layers are involved in it. Now the same contemporary model, there is another contemporary model which is known as TCP/IP model. Now in the TCP/IP model, there are 5 layers. Sorry, 4 layers actually. First is known as network interface layer. Now network interface layer is composed of basically, if you link with it with OSI model, so you will find that it is composed with physical and data link layer of OSI model. This is all known as network interface layer. Now the next layer is known as internet layer, which is basically the network layer of OSI. Next is known as host to host, which is basically the transport layer of OSI. And finally, by combining session presentation application, we are getting application layer at TCP/IP model. Now think the things are same. This is just two thinking speed actually. Two thinking. One we are following. You can think it as a baseline model, or you can think it as a TCP/IP model. But the protocols, set of rules, all the things are basically same. All the things are there. I mean, in TCP/IP model also this FTP, SMTP, POP3, Telnet, SNMP, all the protocols are running. Here in the OSI model also these protocols are running. So we are just thinking it like that. And why we have segregated these things into different layers? Because if you ask this question to me, I will my answer will be to diagnose the problem more correctly. Now suppose you are getting a message when you are clicking on a web page and you are waiting for some time. After that, you are getting a message your session has expired. So if this thing happens, so you can understand that okay, my session related problem has happened. Maybe some session related problem is there. So I have to concentrate on this particular thing. Okay. So there is no application layer problem, there is no presentation related problem, there is no network related problem, there is no network interface related problem. So only problem is of the session related problem. So I can I can check these things. So for better diagnosis and to better analysis, we have segregated this overall thing into different layers actually. So that is the relationship between OSI and TCP. Okay, now both the things is doing the same job. We are just thinking it in 4 layers, or we are thinking it in 7 layers. Okay, that is the thing. And again, I'm telling you the set of rules, set of protocols, whatever we are telling you are same basically. So this is two models. It might come in your exam. That's why I have included this. Now, at your syllabus, the first thing is what is the uses of computer networks. Now, nowadays, I don't have to tell you that what are the uses of computer networks, and especially in this situation. I mean, every time we are using computer network or communication network. So, computer network, it will give you the chance of resource sharing. Whatever resource you have right now, I'm sharing this resource with you. So, resource sharing. It follows server client model. Like suppose there is a server where all the informations are stored, and there is some client from the client we are accessing the records present in the server. So that is the server client model. Okay, next is communication medium. So a computer network can provide a powerful communication medium, like right now we are getting. Okay, so it's a computer network can provide a powerful communication network. Communication medium. Next, the e-commerce businesses like your e-commerce business like the different medical business like Midlife, like Shasta Sundar, like Spencer, like Flipkart. All these are the e-commerce business. So these e-commerce business are getting helped by this communication network. Okay, we are ordering the things online, and they are getting it for us. They're giving these things to us. I mean, they're providing this service. Okay, this is possible because of this e-commerce business. Now again, Ola, Uber, this is also like with the help of this computer network or communication network. Next is retrieving remote information. We can retrieve remote information like right now, remote communication also. Like right now, I'm sitting in my home, and you are sitting in your home, and you are getting this thing. So this is the remote communication is possible. Even retrieving the remote information. That means some information is given at the server, and you are getting it, like Google server. When you are searching on the Google page, so that particular information is saved in the Google server, and we are getting it from our home, from our place. So that is retrieving remote information. And obviously, it's a cost-effective system. because we don't have to bear much cost for getting this kind of information. We are sitting our home where we need one computer or one mobile or one communicating device and some computer network, and we can do that. So there is some cost. This is also cost-effective system. So these are some important aspects of computer network. Okay, so that is the use of computer networks actually. Now, in your syllabus, the next topic is written like that: types of computer network. Now, mainly whenever we are calling types of computer network, mainly in our mind it comes like LAN, MAN, WAN, and PAN kind of thing maximum. Now, these are something, apart from this also there are some kind of computer networks, we will discuss them on them also. So I'm starting from PAN because PAN is, in my opinion, PAN is smallest computer network. Now what is PAN? PAN means personal area network. Now what is personal area network? Like right now, I have this laptop, I have this mobile phone, I have this another mobile phone, I have a printer which is wireless, so I can communicate among them. So that is I'm creating a PAN. Okay, personal area network. It's the smallest, most basic type of network. Okay. Next is a local area network LAN. You know that already about LAN. LAN means within a building we are creating a computer network. That is LAN. Next is wireless LAN. Now what is wireless LAN? Now normal LAN there could be WAT connection. There could be wireless connection. In the WLAN or wireless LAN there will be no WAT connection. All will be wireless connection. Like through your wireless router, you can communicate. You can connect. You can develop a local area network that will be known as WLAN, wireless LAN. Okay. Next is CAN, that is campus area network. What is campus area network? Now suppose in your college you have several buildings. Now if you want to connect all those buildings, like suppose in your college there are several buildings for several departments. Now suppose you want to come, or in your university there are several buildings for the several departments. Now if university wants to create a LAN for the several departments, we will call it CAN, that is campus area network. So within a campus, the communication has happened. That is campus area network. Okay. So obviously it is larger than LAN because a LAN basically restricted to one building. CAN is basically comprises of more than one building. It connects more than one building within a campus, within a boundary. That is CAN. Next is metropolitan area or MAN. MAN is obviously larger than CAN. That is what? That is means we're establishing a network within a city, suppose. That is metropolitan area network. Okay. Suppose one company, one organization has several buildings, several factories around the city. So if they want to communicate, they want to set up a communication network, that will be known as metropolitan area network. Next is wide area network WAN. That is basically nothing but internet, actually internet. It has no shape and all that. I mean, no restrictions. So all over the world it can be. So that is wide area network. Next, another very vital thing is known as storage area network. That is known as SAN, storage area network. Now, what is storage area network? Now, storage area network is basically, suppose I have several servers. Suppose we have several servers, and each server has a capability to store data. Now, among them, some servers are very highly populated. Some servers are very, it has to store lots of data, and some servers are comparatively stores fewer numbers of data or smaller data. I mean, seldomly used. So the server which is very highly populated, I mean, lots of data it has to manage. That servers maybe slow, maybe engaged, maybe full of data and all that. So to overcome that problem, what we can do, we can create a separate storage, separate section for the storage purpose, solely for the storage purpose. So on machine which is dedicated for the storage purpose only, where all the all the memories are inserted. I mean, there are some memories. So that, I mean, what I want to tell you, that that particular machine is used for the used for storing the data only, storage purpose. So that is, and when other machines are interacting with that machine, so we can call it a storage area network. That means there is a machine which is only used for the storage purpose, and the other machines want to get the data. That machines can interact with that storage machine and they can get their data. So that is kind of storage area network. So that is written over here, if you see, as a dedicated high-speed network that connects shared pools of storage devices to several servers. These type of networks don't rely on LAN or WAN. Instead, they move storage resources away from the network and place them into their own high-performance network. And this can be accessed in the same fashion as a drive attached to a server. Okay, like your hard drive attached to the server. So that your machine, that is your server is accessing the hard drive of the machine of its own. Here the hard drive is it is kept in a different place, where only that in that machine only the hard drives are inserted. So all the storages are inserted. So all the machines are accessing its data from that storage machine. So that is and those machines are connected via a network, and that is known as storage area network. Next another is known as system area network, which is also acronym as SAN, system area network. System area network, this term is fairly new actually, within the first few decades actually. It is used to explain a relatively local network that is designed to provide high-speed connection in server-to-server applications or storage area networks or processor-to-processor applications. The computer is connected on a system area network operate as a single system at a very high speeds. So computers, those are connected on a system area network, they operate as a single system, okay, at a very high speed. So that is system area network. So storage area network, all the storages for all the storages we are using a different machine where all the storages are there, and all the machines are connected with that machine via the different connection mechanism. That is storage area network. And system area network is something different. System area network is basically computers connected on a system area network operate as a single system actually at very high speeds. Okay, so all the computers are connected in a system area network and they operate as a single system. Suppose a single unit, single entity, and they operate at very high speeds. That is system area network. Now there is another type of network which is known as passive optical local area network, or POLAN. Okay, it is an alternative to traditional switch-based Ethernet LANs. Now, Ethernet LAN means the cabling. The cable of the LANs are basically generally known as Ethernet LANs. The cable specification of the LAN is basically known as Ethernet LANs. So, POLAN, there is passive optical local area network, which can be integrated into structured cabling to overcome concerns about supporting traditional Ethernet protocols and network applications like that. Now, a point-to-multipoint LAN architecture, POLAN uses optical splitters to split an optical signal from one standard of some single mode optical fiber into multi signals to serve users and devices. Now this is basically a type of network. For your level you have to understand that this is also a type of network which is made up of some optical network, okay, and the full form of it is passive optical local area network. Okay, so you don't have to go much details of it, you just know the name of it at your level. That is, it is an optical fiber network. Okay, LAN network, optical fiber LAN network. Okay, that is passive optical local area network. Next is enterprise private network. This is the network designed for some specific enterprise, specific organization. Now, virtual private network. Now, virtual private network is very important in my opinion, because virtual private network give you the access to access to internet very securely actually. Virtual private network is a mechanism through which you can access the internet, but you can access it very securely, because whenever you are accessing internet, you are accessing actually public network. Now public network, there may be trusted, maybe may not be trusted, but if you access it through via virtual private network, then it will be a secure way of communication. So that is the main essence of virtual private network. That's why it is known as private network, as if it's a private network. That's why it is known as virtual. It is not private actually, but it is as if it is acting for you only. It is working for you only. So virtually, as I'm telling it that as if, so that is virtual kind of thing. It is not you, but it is acting as like it is you. That is virtual private network. So what it gives us security to access data over internet. That is virtual private network. So these are the different types of networks. I again recapitulate. PAN, personal area network, okay, in your home. Local area network within a building. Wireless area network, that is again within a building wirelessly. Campus area network within a campus, like an university or like some offices and all that. Metropolitan area network within a city. Wide area network like internet. Storage area network, storage related. System area network, system area network, multiple machines connected to each other but using acting as a single system at very high speed. Passive optical local area network, this is made up of optical fibers and it's a local area network again. Next is enterprise private network. This type of networks are built and owned by some businesses and all that. Virtual private network, secure way of accessing the internet. That is virtual private network. Okay. Hopefully you have understood this. If you have any doubts on it, you can ask me via Google Class or via WhatsApp or via phone. Now network topology. There is another terminology, network topology. This is something different. Network topology. Now topology, what is topology? Topology means how your machines are arranged. How your machines are arranged. This is known as topology. How the machines are arranged in a different way. That is known as topology. Now there are different kinds of topology. The first topology is known as bus topology. This is the picture of the bus topology. You can clearly get it. There is a cable. With those cables, the nodes are connected. So this is bus topology. It is cost effective. Advantage is very cost effective. Disadvantage is if the cable fails. Suppose here the cable fails, cable breaks. So you cannot communicate with this machine to this machine because cable is broken down over here. So this is a disadvantage. So this is known as bus topology. So the machines are arranged in a bus. Bus means communication media, communication line. So that is bus. Next is what? Ring topology. Machines are arranged in a kind of ring. This is a ring. Okay, ring topology has an advantage. If this particular line broken down, I can communicate this way. If it is a bidirectional link. Okay, so that is the ring topology. Advantages are written given here. Just go through it. Next, stack topology. Now in the stack topology, there is a central hub. We call it hub. Central machine actually. Central connector. You can say central connector. With that central connector, all the machines are connected. That is stack topology. Okay, so here the risk is if this hub goes down, all the connections gone. Your network down. Okay, that is the stack topology. Okay, next is mesh topology. Now mesh topology means all the machines are connected to each and every machine. Actually, this machine is connected with this machine is connected with this machine is connected with this machine. Again, in the same way, this machine is connected with this machine is connected with this machine is connected with this machine. So here the disadvantage is number of connectors are huge. And that number of connectors, if you calculate here, how many number of nodes? 4 number of nodes are there. So if I say that n equals to 4, so number of connectors is n into n minus 1 by 2. That is 4 into 4 minus 1 means 3. When it's 3 into 4 is 12. By 2 means 12 by 2 means 6. So how many connectors are there? 1, 2, 3, 4, 5, and 6. So there are 6 connectors needed. So that is the disadvantage of mesh topology. Now here are only 4 networks. Now when there are 400 nodes, so how many number of connectors will be needed? Huge. So that's the problem with mesh topology. Okay. Now there are two divisions of mesh topology, 2 types of mesh topology again. One is known as partial, another is known as full. In the partial mesh topology, some of the links are in mesh topology, some of the links are not in mesh topology. But in full mesh topology, every nodes are connected in the mesh topology. I mean, each and every nodes or devices are connected to each other. That is full mesh topology. Partial mesh topology, in this topology, some of the systems are connected in the same fashion or mesh topology, but some devices are only connected to 2 or 3 devices. So that is partial. So partial mesh topology, full mesh topology. Okay. Now tree topology. Now tree topology is look like this. This is a tree topology. Every tree has a root. Tree is basically a graph. A graph without a cycle is known as tree. That is again may not be in your syllabus. So that is a tree. This is the structure of a tree actually. Tree, there is a root, we call it a root. Now this is a parent, this is parent, these are the childs actually. Again, this is a parent, these are the child. So every parent has some child, and like that. This is a tree topology. So when machines are arranged in this way, this is known as tree topology. Okay. Now in hybrid topology. In the hybrid topology, we can use different kind of topologies. We have mixed it. We have mixed up different kind of topology. Some of them are in bus topology, some of them in some other way. These are the tree topology like that. So that is the hybrid topology. Okay. So these are the types of topologies. I mean, how the machines are arranged in a network. That is known as topology basically. So there are different kinds of topology. Again, recapitulate once again. One is known as bus topology. Another is known as ring topology. This is a ring topology. Another is known as star topology. Next is known as mesh topology. Here the number of connectors are huge, I have told you. Next is known as tree topology, so tree-like fashion, tree topology, that is parent-child fashion. Okay. Next is hybrid topology, mixed kind of thing. Okay. Next is what are the network devices? What are the network devices generally used in computer network? So these are some of the network devices which generally used in the computers, in the computer network actually. One is known as hub. You have already seen hub is used in star topology. Next is known as gateway. Another is known as router, repeater, bridge, and switch. So these are some devices computer used in computer network. Now, in those devices, some of the devices are used in some layers, some of the devices are used in some other layers, and like that. What are the layers? That means, suppose if I tell you hub and repeater. Now, hub and repeater are used at the physical layer of the OSI model. It is used at the physical layer of the OSI model. Hub and repeater. Remember, hub and repeater it is used at the physical layer of the OSI model. So that's why we can call it layer 1 device. Because physical layer, I'm calling it a physical layer is layer 1. So physical is layer 1, data link is layer 2, network is layer 3, transport is layer 4. Okay, so layer 1, layer 2, layer 3, layer 4, in that way layer 7, physical data link, network, transport, session, presentation, application. So among them, hub and repeater, these two devices works at the physical layer. Okay. Next, this bridge, it works at the data link layer. Bridge works at the data link layer. Again, switch also works at the physical layer. Okay. Now bridge works at the data link layer. Okay. Gateway and router works at the network layer. Gateway and router works at the network layer. So we'll come to the details of these layers. What is repeater? So repeater operates at the physical layer. Its job is to regenerate the signal actually. Regenerates the signal over the same network before the signal becomes too big or corrupted so as to extend the length to which the signal can be transmitted over the same network. So it basically regenerates the signal. Like in our electric line, we use transformers. So transformer, what is the job of the transformer basically? It regenerates the electric signal. So here also the repeater regenerates the signal, communication signal. Okay, it regenerates the communication signal. That's known as repeater. Next is hub. Now hub is basically it's a multi-port repeater. Hub is basically like repeater, but it's a multi-port repeater. That means in a repeater, if there are one or two connectors, we call it port. One or two connector. Hub has multiple ports, more than one ports or more than one connector, so that it can connect two segment of LANs. Okay, suppose in one LAN there are 10 machines, another LAN there are 10 machines. We are connecting those two LANs with the hub. So we need 10 connectors. Okay, ports. So that is the hub. Okay. Now hubs are of two types, active hub and passive hub. In the active hub, these hubs which have their own power supply and can clean, boost and relay the signal along with the network. It serves both as a repeater as well as varying center. That is how it can serve the purpose of repeater also. Passive hub it is generally it only passes the signal. That is passive hub. So active hub regenerates the signal, passive hub only passes the signal. Okay, this is passive. Now what is bridge? A bridge works at the data link layer. So that is bridge. Bridge works as a data link layer. Bridge operates as a data link layer, which is a repeater. Bridge is a repeater which adds on the functionality of filtering content. Now, bridge basically it is known as a filtering device. Bridge is known as a filtering device. How? Suppose you have two segment of LANs. Okay. Now your total network is connected with internet. Now from the internet, when some data is coming, that data do not know in which section of LAN it has to move. I mean that data is for somebody, some machine, some particular machine. Now that data, that particular thing don't know to which machine, which section of LAN that particular machine is there. So what it will do, it will come to the bridge. If there is a bridge, it will come to the bridge. Now bridge will decide whether to pass the data to other section of the LAN or the machine, the sender, the receiver machine is at the the other part of the LAN. I mean, suppose there are two parts of the LAN. Okay, two parts of the LAN. One message is coming for suppose machine X. Now there are two sections of LAN. Suppose LAN A, LAN B. Under LAN A, some of the machines are there. Under LAN B, some of the machines are there. Okay. Among them, under LAN B, suppose machine X is there. Okay. Now some message is coming from the internet. That message is coming to the internet, coming from the internet, it has to move to node X. Now that particular message, it has no information that whether that machine X resides. Okay, whether it is in LAN A or it is in LAN B. So if it is in LAN B, so bridge will decide that. Now bridge knows that machine X is under LAN B. So if that particular message which is coming from the internet is for machine X, then only that particular message will pass the bridge and it will reach to machine X. Otherwise, it will not pass the bridge. So in that way, we can filter the machine data. We can filter the data, and that in that way, the bridge is known as filtering device. So now think, suppose from internet, crores of messages are coming. Now, if crores of messages are reaching to each and every part of the LAN segment, so there will be a data flooding. Okay, and your network will be jam and all that. So if there is a bridge can rectify that thing in many, I mean, very easily. Okay, so that is the purpose of bridge. So bridge operates a data link layer. It's a repeater with add-on functionality of filtering content. That's why it is written. Add-on functionality of filtering content by reading the MAC address of the source and destination. Now, what is the MAC address? What is the MAC address? I have told you that there are two types of address: logical address and physical address. So MAC address is the physical address. Okay, medium access control, MAC. So MAC address, medium access control address, that is the physical address. So it is also used for interconnecting two LANs working on the same protocol. It is a single input and single output port, thus making it a two-port device. So bridge is a two-port device, single input, single output. With that single input, some machines are connected, maybe some machines are connected over here. So there are bridges connecting two set of LANs. Okay, you can say. Now, there are two types of bridges. One is known as transparent bridge, another is known as source routing bridge. What is transparent bridge? These are the bridge in which the stations are completely unaware. The stations which are connected to the bridges are completely unaware of the bridge's existence. Stations don't know whether the bridge is present in the network or not. So they're completely unaware of that. Okay. In the source routing bridge, here the machines are aware that there are some bridge. So in the transparent bridges, these are the bridge in which the stations are completely unaware of the bridge's existence. Therefore, whether or not a bridge is added or deleted from the network, reconfiguration of the station is unnecessary. That means if I delete the bridge, if I remove the bridge from my network, then if those nodes are unaware of existence of the bridge, so I don't have any headache. I can remove one bridge or I can add one bridge. There is no problem because I don't have to inform anybody else. Because my network is designed in such a manner that my nodes are not aware of this. But in source routing bridge, I cannot do that. In the source routing bridge, routing operation is performed by source station and the frame specifies which route to follow. Here, routing operation, that means the way in what way my data will move, that is known as routing operation. Routing operation is performed by the source station. Source station means from where the data is coming. Okay, and the frame specifies which route to follow. Okay, so the data will specify, the frame will specify which route to follow. The host can discover frame by sending a special frame called discovery frame. Okay, the host can discover the frame by sending a special frame, special data, special information, you can say, called as discovery frame, which spreads to the entire network. It is spreading to the entire network using all possible paths to destination, and in that way, it is finding its route. Okay. That is source routing. That means that particular frame, we are calling it discovery frame. That frame is spreading through the different sections of my network, and it gathering the information about the structure of the network, so that I can send my data in some way. Okay, so that is known as source routing bridge. And transparent bridge, there is my nodes are not aware of this present of this bridge. Okay, but source routing bridge, my nodes are well aware of the existence of the bridge. Okay. Next is switch. Now switch is another device. As I told you, it's a multi-port bridge basically. Okay, this is the picture you can see. This is the picture you can see. This is the router. I have not talked about router till now. About the router. This is the hub. Okay, this is the switch. Now switch is a multi-port bridge with a buffer and design that can and the design that can boost its efficiency and performance. A switch is a data link layer device. I have told you, switch is a data link layer device. It's a data link layer device. Perhaps I have told you that switch is a physical layer device. Switch is a data link layer device. That means layer 2 device. Switch is layer 2 device. Okay, data link layer device. The switch can perform error checking before forwarding data. That means whenever data is forwarded, before that switch checking then whether there is any error or not. Okay, forwarding the data before forwarding the data, and that makes it very efficient, and it does not forward packets that have errors and forward good packets selectively to correct port only. Okay, it only forward the good packets but there is no error. So that is the very advantage of switch. Okay, now again I'm telling you switch works at the data link layer 2 device. Okay, next is the router. Now router is a very vital device. Router, it basically works at the network layer, and it's a very vital device because it gives us the optimum route to my destination. It gives us the optimum route to the destination. It gives one particular node in what way that node will forward its data towards the destination. Now suppose I want to move from place A to place Y. Place A to place Y. In between I have several other places where those places I have to move. And there are several routes to reach to place Y. I will follow only that route which is optimal. So that particular thing is done by router. So router is a device like a switch that routes data packets based on their IP addresses. IP address is known as logical address. Okay. Now router is mainly a network layer device. Router normally connects LAN WANs together and have a dynamically updating routing table based on which they make decisions on routing the data packets. Actually, router follows a matrix kind of table where at some part there are some source stations are written, at other part some destination stations are written, and in between the intermediary nodes are there. So by following that kind of table, router forwards data. Okay, so it has some table, we call it routing table. By following that routing table, it forwards the data. Now there are two kinds of tables. That means there are two kinds of routing mechanism: static routing mechanism, dynamic routing mechanism. In the static routing mechanism, the table is fixed. In the dynamic routing mechanism, table is dynamic. Now, the disadvantage of the static routing table is that suppose you want to move from node place A to place B. In between C and D nodes are present. Now that is the only path information written in the routing table, and it's a static routing table. Now by some reason your node C is down, then you cannot reach place A to place B because your path is the path between place A to place B is CD via CD. So among them C is down, so you cannot reach, and you don't have any other option. But if it is a dynamic table, that can be dynamically changed. That means suppose the path that node C is down, so there is an alternative path. There is an alternative path maybe via node E and node D and node E. So you can choose that alternative path, and that path information will be entered in the routing table. So that is the case with dynamic routing table. Okay. So router gives us the optimum route to the destination. It has two mechanisms: static routing and dynamic routing. In the static routing, paths are fixed between source and destination. Dynamic routing, paths are not fixed; it can be dynamically changed. And in both the cases, we use some table. You can use a table. It's a matrix-like table. So that is about router. Okay. What is gateway? Now gateway is basically it can connect to dissimilar network. Gateway basically connect to dissimilar network. To dissimilar network means some network is made up of Windows administration, Windows machines, Windows operating system. Some network which is may not be which is maybe running on Linux machines, Linux operating system. So that kind of network, different kinds of network can be connected by a gateway. So as a gateway, as the name suggests, is a passage to connect two networks together that may work upon different networking models. What I have told you. They basically work as the messenger agents that take data from one system, interpret it and transfer it to another system. Those are also called protocol converters because in the Windows machine some protocols are running, in the Linux machine some other protocols will be running. The protocols are contemporary protocols but different protocol. So that conversion is also done at the gateway level. Okay. Now with this router, there is another device known as router. Okay. Coming to the gateway is also works at the network layer. Okay, gateway also works at the network layer. Now router, it's a combination of bridge and router. It's nothing but the combination of bridge and router. It is also known as bridging router. It's a device which combines features of both bridge and router. It can work either at the data link layer or the network layer. Working as router, it is capable of routing packets across networks. Working as bridge, capable of filtering local area network traffic. So it can act as both router, combination of router and bridge. So what type of devices we got? We got hub, we got repeater. Now hub, multi-port repeater actually. Okay, repeater regenerates the signal. Hub, multi-port repeater. Two types of hubs are there: passive, active. Passive hub only connects. Active hub regenerates the signal also. So it is also like repeater. Next is bridge, works at the data link layer, and it is works as a filtering device, local network traffic. It can filter local network traffic, that is bridge. Then switch is also works at the data link layer. Okay. Next is gateway and router. Now gateway can connect to the similar networks. Router, it can gives you the optimum route to the destination. Both router and gateway works at the network layer. Okay, so this is all about the network devices. What you have to know as per your syllabus. Okay. Next is, there is a difference between router and gateway I have given for you. Let's go through it. The primary function of router to ensure that data packets are switched to the right addresses. Data packets are moving to the right addresses. Gateway to connect to the similar networks. Now there are some features. This is known as DHCP, means the dynamic host configuration protocol. DHCP. NAT means network address translation. So these protocols are there involved in the router. And in the gateway, protocol conversions happens at the gateway. I've told you. VoIP means voice over IP. PSTN means public switch telephone network. Voice over IP, this is public switch telephone network. So this conversion has done by the gateway. So basically, you can write protocol conversion happens at the gateway. You don't have to go into the details. Okay. So you just write, you can write protocol conversion can happen at the gateway. Okay. Next is dynamic routing, supported at the router level. Gateway not supported. Hosted on dedicated appliances, and here dedicated or virtual appliance or physical server. Okay. Related terms: internet router, Wi-Fi router. These are the related terms with router, and with the gateway, that is proxy server, gateway router, voice gateway, like that. OSI layer. OSI layer 3 and 4 works on 3 and 4. 3 and 4 means physical is layer 1, data link is layer 2, network is layer 3 actually. So network layer, transport layer. So network layer actually works on network layer, router works on the network layer. Sometimes it can go to the transport layer. So OSI layer 3 and 4 means network transport, and gateway works up to layer 5. That means physical data link network transport and session. Physical data link network transport and session. So works up to layer 5. Up to layer 5. Okay. So that means layer 5 means starting from network. Okay. Transport session. Actually up to session. Okay. The working principle of the router: installing routing information for various networks and routing traffic based on destination addresses. And we are differentiating what is inside network and what is outside network. That is gateway. So these are the difference of router and gateway. Now another difference I have given for you, that is difference between router and bridge. I thought it may come also, so that's why I have included it. Router and bridge. So router operates in network layer of ASI model, as I told you. Bridge operates in data link layer of ASI model. Router is used to connect the LAN and WAN. Bridge is used to connect to different LAN segments. That is bridge. Okay. Router transmits data in the form of packets. Bridge transmits data in the form of frames. That is very vital difference. And short question will come on this also. Router transmits data in the form of packets. When router transmitting the data, it is in the form of packet. What I can tell you, it has some logic also. So router transmits data in the form of packets, and bridge transmits data in the form of frames. Now router reads the IP address of a device, bridge reads the MAC address of a device. There is a very other very vital difference. Router reads the IP address of a device. IP means Internet Protocol address. That is the normal IP address of IPv4 of 32 bytes or 32 bits, or IPv6 is of 128 bits. Okay. IPv4 has a two version. IP has a two version. IPv4 32 bits, IPv6 128 bits. So any IP address, router is the IP address of a device, and bridge is the MAC address of a device. Another is router has more parts compared to bridge. Bridge has only two ports. Router has more ports compared to bridges. Okay, and bridges has only two ports. Another is router uses routing table for sending data, as I told you, static routing table, dynamic routing table. Bridge does not use any routing table for sending data. That is the difference. That is the main difference between routers and bridges. So router used much more ports. Bridge use only 2 ports. Router do not use any routing. Router uses routing table. Bridge do not use any that kind of table. Okay. Router works by the help of IP address. Bridge works at the help of MAC address. And these are some very basic differences between router and bridge. What you have to remember. Next, the last section of your module 6, that is the differences between internet, intranet, and extranet. So, what is internet? What is intranet? What is extranet? I have given you. I have tried to given you by this picture. Now, suppose if you see this, that's the smallest circle, which is known as intranet. Now, intranet is basically, it's basically here you can see that suppliers and partners. Okay, these are the company actually. The intranet you can see this is a company. That is my own private network. When I have developed my own private network, that is known as intranet actually. When I have developed my own private network, that is the network of a company. That is intranet. Okay. Extranet is what? Extranet is my own network and the network which I used to connect. I mean I connect with those networks. Like suppose I have a company and I have some suppliers and some partners. So when I am connecting my network with my suppliers and partners network, so it's becoming extranet, which is the superset of my own network. That is extranet. And internet is the whole world. When all the networks are connected, that is internet. So intranet is my own private network, extranet is my network and some of my trusted networks, that is extranet, to which I'm connected. I used to connect and I generally establish connection. And internet is the whole overall worldwide network, that is internet. So that is written over here. Internet, there is a network that is accessible. Internet, there is a network that is accessible to a person who knows their IP address. It is global communication access through the web and other thing. Intranet, this is the network that is not available to the world outside of the intranet. Okay, it is my own private network, that is intranet. And extranet, this is actually an intranet that is partially accessible to authorized outsiders. Only when I have authorized, they can access only. That is extranet. That means my trusted networks. So that is extranet. So these are some differences. Description, size of network, okay, purpose, content of the network, ownership. Internet has no ownership. It is everybody is owner of it. And if I talked about intranet, so intranet is ownership of intranet is by a single organization, and ownership of extranet is by a single or multiple organizations. Now suppose I can develop my our extranet, my own network and your networks, my students' networks. So I can develop an extranet. An intranet is overall worldwide network. An example of internet is the network you can use in Google and all that. All it's internet. An example of intranet is a company like some ExxonMobil or some any company is developing their own network, that is intranet. And example of extranet is when companies like HP, Intel, and different companies decide to use the same network for related business operations. Like suppose they are for their partners, they're incorporating their partners' network into their own network. So that is becoming extranet. So these are basically intranet, extranet, the differences. So hope you will be benefited by this video tutorial. If you have any doubts, any clarification, any question, you can ask me via Google Plus, as I will upload this to the Google Plus. You can ask me via Google Plus, or you can WhatsApp me in my number, or you can call me. Okay. So today I'm ending my lecture over here. Thank you.